Good morning, students. Today we discuss about topic is design of experiments, particularly how to work in Minitab software. Design of experiments. Design of experiments is a systematic method to determine the relationship between factors affecting a process and the output of that process. In other words, it is used to find the cause and effects relationships. This information is needed to manage process inputs in order to optimize the outputs. What are the steps to obtain good results from DOE? Select process variables, select an experimental design, execute the design, check that the data are consistent with the experimental assumptions, analyze and interpret the results, use or present the results. These are that Minitab 14 version software. This place is used for to collect the statistical results of our data analysis. This is that worksheet. The worksheet is a spreadsheet interface to input, sort and manipulate data. How to obtain the data? Manually it's possible to enter the data or open an existing Minitab worksheet file or copy and paste from the Excel spreadsheet. First you go to start, then you have to choose the design of experiments. Then the 4 design is available: factorial, response surface, mixture, Takuchi. In this case you have to choose the Takuchi design. Then you have to create the Takuchi designs. How to create the Takuchi design? Before have to see what are the parameters and levels chosen for the particular work. In this case you have to choose 3 parameters: spindle speed, feed rate, depth of cut, and levels. 4 levels you have to choose. The values are given. The values is chosen based on that reputed journals. Otherwise the experimenter have experience, so based on the experience you have to choose that values. The values it's focus on that CNC machine specifications, and what are the specifications available, based on only you have to choose that one. This is the results obtained for the proposed experimental plan: coded factor, natural factor. This value have to taken from the Takuchi create design. This is a spindle speed, feed rate, depth of cut. It's a natural factor. Already said that 4 level you have to choose 500, 1000, 1500, 2000, and also you have to take in that feed rate and depth of cut. Based on you have to give that value. Corresponding values you have to choose. This is that output responses. We have to, in this case, you have to choose an surface roughness and MRR. Surface roughness calculated based on surface roughness tester. MRR, material removal rate, is calculated from that formula. So already the particular work did and published materials today proceedings through Triple M conferences, NIT Trichy. So next, already I said that 3 factors and 4 level. Then you have to Takuchi design, have to choose on 4 level and 3 factors, and have to choose the display available designs. Next we seen that. So this type of arrangements you have to show. Then you have to see 4 levels. It's only one possible, 16 experiments only to possible to conduct in this case. That's why we have to conduct 16 experiments. So only one possible way is available. So we conducted 16 experiments. So next, Takuchi designs. How to interpret that values of the particular locations. In this case you have to type that speed, feed and depth of cut. In this place you have to give that value, speed, feed and the depth of cut. In the feed 500, 1000, 1500, 2000, feed rate 0.2, 0.4, 0.6, 0.8, and also corresponding DOC value we given 0.5, 1, 1.5, 2. Then you have to give that to OK. Before you have to check 2 columns of the array, the specific below value is marked. Then store the design worksheet, then give to OK. Automatically the value is given. The Already we seen that value in that sheet, so that automatically that value come here in the sheet. Then you have to copy that value, surface roughness and MRR. Already we found with the, then have to start DOE Takuchi. Now you analyze the data. First initially you have to create, now you have to analyze the data. Analyze the Takuchi design, so surface roughness and MRR. So you have to choose, if you want to choose the TSR separately, you get that graph. If you want to choose MRR, you get that graph individually. So what are the details you have to need? Means, if you want to means, you have to choose the mean only. If you want both signal to noise ratio, means you have to choose that signal to noise ratio and means also. So in the particular experimentations, we have two outputs, surface roughness and MRR. Surface roughness always lower is good, MRR always higher is better. So in these cases, not possible to combine together. So individually have to handle that work. The speed, feed, depth of cut, and have to enter that surface roughness value. We have to choose and analyze the Takuchi designs. You have to choose the smaller is better. Then you have to get that value on the particular locations. Takuchi analysis for a signal to noise ratio and response table for means, and also get that corresponding graphs you have to collect from that minute tab. This graph main effects plot for SN ratio, this graphs for main effect plot for means. The same procedures you have to follow, but to give that larger is better. Because of MRR, almost larger is better is good, so that's why you have to choose the larger is better. The same input, speed, feed, depth of cut, but corresponding is given only that MRR values. Finally we get that same Takuchi analysis for MRR individually, signal to noise ratio and mean value, and main effects plot for SN ratio and main effects plot for means. Minitab design of experiment commands include the following features: catalogs of designed experiments to help you create a design, automatic creation and storage of your designs after you specify its properties, display and storage of diagnostic statistics to help you interpret the results, graphs to help you interpret and present the results. So in these cases only you have to see individually. So not a combined multiple objective you not discussed, only for single objective only have to discuss. Thank you.